Welcome to our talk, everyone, and thanks for being here. We're excited to share our journey, beginning with our humble first steps into Unreal 5.0, progressing through the challenges, and arriving at where we are today. It's been an adventure filled with a lot of learning and experimentation, and there is definitely a bright future for us with Unreal Engine. Before we dive deeper, please let us briefly introduce ourselves. My name is Devold, and I'm a rigging supervisor at Brown Bag Films.
And I'm Michael. I'm the pipeline supervisor at Brown Bag. We both have been part of the amazing team at Brown Bag Films for many years. I think we started more or less the same time.
Yeah, that's 8 years ago.
Wow, it's been a long
It's
time.
been a journey, for sure.
Throughout our time at Brown Bag, we've had the privilege of working on some great animated projects. We are quite happy to be sharing some of those processes with everyone today. But first, we'd like to give a quick introduction of who we are as a studio and the type of shows that we produce. For over 30 years, we've delivered high-quality animation and brought various stories to life to our global audiences. We have a global team of around 800 people spread across the different offices in Dublin, Toronto, and Bali. In addition to developing original IP for our clients and ourselves, our clients include Disney, Netflix, Nickelodeon, and Apple TV. These partnerships have been critical in driving our innovation, our growth, and expanding our creative reach worldwide. With that in mind, these are examples of the type of shows that we produce. A typical show generally has around 500 minutes of animation, and it's scheduled to complete over the course of around 18 months. To accomplish this, we have teams of around 150 crew members per show. And out of these crew members, we have about 50 dedicated animators. Normally, we would have multiple productions running at the same time. This would mean we would have up to 250 animators working across all of our CG productions simultaneously. Due to this type of scale, it is important that the animation pipeline and processes is as streamlined as possible. We do believe Unreal is an important part of that animation process, and we'd like to kick off our humble Unreal story right from the beginning.
Our journey began back in Unreal 5.0, exploring the potential and seeing how far we can take this powerful game engine. Can we make it do what we need it to do for linear content? From those initial experiments, we progressed to our first client-backed project, a bit named Play, utilizing Unreal 5.3. From those building on that experience, we are embracing Unreal 5.5 for multiple full-scale productions currently in progress. Continually refining our workflows and discovering new efficiencies. Currently, we're actively transitioning to version 5.6, embracing the latest improvements and advancements. Throughout this journey, we've explored intermediate versions of Unreal, carefully evaluating fixes, improvements, and upcoming features. Now let's take a step back in time to where it all began.
3 years ago, the first version of Unreal Engine 5 was officially released. Looking back then, we were quite blown away by all the cool demos that was shown. Even today, the tech behind us is still quite impressive. What really caught our attention was Lumen and Nanite. The fact that we have some form of good quality, real-time, global illumination was quite the game changer. Traditionally, as everyone knows, global illumination is an expensive part of the traditional render pipeline. So naturally, we were quite excited to see what Lumen had to offer. During this period, it seemed like it was the perfect time to start exploring and see what was actually achievable within Unreal. There were certainly more questions than answers, and some of the biggest questions we had was around how to handle animation. Should we animate in Engine, or should we animate in Maya and render in Unreal? And naturally, when you ask that question around animation, the next question would be, what is rigging like in Unreal? We did have a few engine skeptics, especially around animation.
Guilty as charged.
I guess now that you're here, you're probably
Yeah, I'm here, aren't I?
you're not as
I've made it
skeptical
this far.
um, because of this test that we were going to do, we were determined to find out what animating in Unreal was going to be like. Before we go into all those unanswered questions, we'd like to show you a clip of our very first experiment, which we called the Space Show.
Attention all crew! Kazar is in danger! Everyone to the bridge! I need ideas, people!
Stellar Squad, assemble!
Except you cadets.
So by now, it's probably no secret that we decided to go all in Engine. That being said, there was still a backup plan for us to fall back into animating in Maya if needed. So what we opted for was to build our rigs with our standard rig builder so that we have fully functioning Maya rigs, and then we would restructure the skeleton and export what we needed into Unreal. That way we had that fallback. So while the scripts and storyboards were being drafted, we took the opportunity to familiarize ourselves with Unreal Engine. For many of us, it was the first time using Unreal, and it was quite intimidating and daunting with how complex Unreal Engine is, with all the different editors and views. And yeah, it was quite a challenge for us. But even with that, one thing that we all recognized was how elegantly you can work with shots in Unreal on your sequence. So you can see all your shots in sequence. That was pretty powerful. So let's talk a little bit about what what Control Rig brought to the table back in 5.0. When we started working with, when we investigated rigging inside of Unreal, one of the interesting things that we realized was that Control Rig is fundamentally procedural. So it's more akin to visual coding than actually a dependency graph like you have in Maya. They both have nodes and wires and behave very, very differently. So next up, reusability. Functions are easy to share, and once you've implemented, if you solve the problem, you don't have to redo it. For instance, if you have a squash and stretch of the spine, you can easily reapply that to get squash and stretch in the leg and squash and stretch on the arm. So that was quite powerful. Another concept, what I like to call the prototype is the code, was very, very advantageous. So with Maya, if you need a new module, first you need to prototype it, and then essentially you need to convert that into code before you can actually make use of it in a full production. So the great thing about Control Rig is that you already have that. Once you build your prototype, you already have what you need. You don't need to code. So that was very powerful for us as well. So it means that you don't need a coder, a middleman to build out your module library. And another thing is the event system. That's also something that was very, very powerful, especially the construction event. So what that allowed us is execute tasks that run on the initialization of the asset so that we can actually snap our rig hierarchy, control hierarchy, to the skeletal mesh. And this is all automated, so it meant that you can use the same control rig and adapt it to different skeletal meshes.
On the prototype as code, did it save you a lot of time because you didn't have to write code?
Yeah, I think it saved a lot of time, but more than that, it lowered the barrier of entry for somebody to be productive and contribute to our model library. So, for instance, we've got a very senior rigger. He always does most of our rigs, and he could now directly contribute his modules into our module base without needing our TD, freeing our TD up so that he could spend time doing other stuff.
Nice.
So Control Rig gave us a solid foundation, but we still had to make it work for our pipeline. So one of the things that we introduced was BBF modules. So this is not to be confused with the modular rigging system inside of Unreal. This was our modules that were control rig counterparts to our Maya modules. So we tried to mimic the behavior as much as we can, and this would ensure that the hierarchies are compatible. So, and we tried to keep the behavior the same, so that for the animators it's not jarring, and for the riggers it's also kind of, we already had a solid foundation of what the animators wanted. Another challenge was geometry handling. So since Unreal doesn't have subdivision surfaces, we had to find a way that we could get meshes that has high enough detail into Unreal. So first we tried to get we subdivided our meshes and did all our rigging and blend shapes, but what we found was it was way too heavy and cumbersome to work with. So what we opted for was to keep working and rigging on the low resolution meshes, but then we would subdivide it and bake the blend shapes and the skinning onto the subdivided mesh. So this helped us to keep working as we always have, and then get the detail that we needed into Unreal. As mentioned earlier, we developed an exporter to deal with this process. So this gave us continuity. It meant that we could automate that process and have that as a bridge between our Maya and our Unreal. So that meant that we had a solution to take it from Maya to Unreal.
It's common knowledge that Unreal has a very capable and fast renderer. We were somewhat surprised that we were able to skip the entire pipeline phase just because of this aspect of Unreal. There was one specific shot that gave us the opportunity to explore how we elevate our approach to compound shots directly within Engine. The final shot that you see over there required varying lighting setups and distinct backdrops for the different character plates. Instead of approaching this in the traditional way, we experimented with the sequencer to test out a simple technique that would allow us to stay within the engine. The first three shots are our compound shots, and they got rendered out first. The output of those three compound shots, they became inputs as the plates of the final shot. Any changes to the initial compound shot would propagate to the final shot, and because the renders happened really quickly, we didn't care if one or two or all the compound shots changed. We just rendered the whole lot. In fact, we actually rendered the entire episode every single day, and this became what we called the nightly renders. While we've been giving quite a lot of praise to Unreal, we did run into some issues. There was feedback from the animators that the audio scrubbing experience was not what they were used to. So trying to animate and especially lip sync to the audio proved to be quite a challenge back then. To work around that, we actually just came up with a simple tool that would sync Unreal's playhead with Maya's playhead. The audio would get loaded up in Maya, the animator would work in Engine, and then the audio would just come out of Maya. The tool was a simple blueprint that got spawned into the level sequence, and it would just send the current frame to Maya via the command port. We are actually quite happy that later versions of Unreal actually improved the audio syncing experience. So we were actually able to retire this tool. No more Maya for the animators.
Thank goodness.
There does seem to be some improvements to 5.6 in the audio syncing as well, so we're quite happy and we're looking forward to that as well. Reflecting back on this, the tool did get the job done, It allowed the animators to be a bit more productive, and it certainly did help push the project out in a timely manner. As the space show got completed, and everyone being really happy and proud of our very first Unreal creation, we said goodbye to 5.0 and set our eye on the next versions of Unreal.
So between 5.0 and 5.3, there was a bit of time for us to refine our internal processes and pipeline tools. Even with various discussions on what we should and could improve, there was a debate that we clearly need another project. So along came Play. The project provided us with a very unique challenge that involved very elaborate deformation of a character named Jelly. So there's actually an in-depth talk on the subject by two of our colleagues, James and Luke, and you can follow the QR code to get the video. So by the time we hit 5.3, we were starting to feel more confident working in the engine. The Space Show project gave us the playground to see what Unreal has to offer, but it also showed us where Unreal's rigging toolset still needed to evolve. Thankfully, Epic was clearly listening to what the rigging community needed. So between 5.0 and 5.3, we started to seeing some exciting updates to Control Rig and its supporting tools. So let's take a look at what changed. So the first one was spawn control nodes, or spawn object nodes. What this allows us to do is to actually dynamically create our entire rig hierarchy. So it meant that we didn't need to set that hierarchy up manually anymore. And we don't need to copy it from asset to asset. And it also enabled us to have all of our functionality inside one node. That's all you needed to create your control rig structure, the rig hierarchy, and the behavior. So that was a game changer for us. And then also along came deformers, which was very powerful. And that was one of the main challenges for us coming from Maya, is the fact that we didn't have any deformers. So the deformer graph was super powerful. You could literally code your own deformers, but it also was a little bit complex and difficult to set up. But more on this later. Another very valuable addition was metadata. So what metadata allowed us is to take information from one event to another event. So for instance, you could take the length of your spine for the construction event, and then in the forward solve, you can compare that to the current length, and you can calculate the amount of squash and stretch you need to apply. Very subtle feature, but it was very powerful in helping us to create more procedural rigs. So, and then the last one was the skeletal editor. So this was very exciting as well. Skeletal editor allowed us to actually build bone hierarchies for skeletal meshes and also do weights directly inside of Unreal. But unfortunately for us, it still was lacking some of the features that we needed before we can actually roll it out into production. So a few things that we implemented in 5.3 was, thanks to the spawn object nodes, we could make our modules 100% procedural. So that meant you just place one node there, and that would build the hierarchy and the behavior and everything. And then the second thing that we needed to look at was to create we needed a central location. Because we work on multiple projects at the same time, we needed a central location for us to be able to manage our update our modules and also roll out that to all our projects. So a content plugin was actually the answer for this. So we created our BBF rig plugin, and this just allowed us to have one central location in one repo where we updated and developed our modules, and all the projects had access to it. Along with that was also versioning is something that we had to take care of, because we have multiple projects and some of those projects run multiple seasons. So we had to find a way to so that we can still keep developing our assets, our modules, but without breaking existing scenes or animation. So what we looked at was a very simple versioning system, but it seemed to get the job done. And then the third thing was expand joints or corrective, I guess, corrective poses, you could also say. So expand joints is for where you need to preserve volume, for instance, in the shoulders, the hips, knees, etc. So we had an expand joint. We tried the Epic Pose Wrangler for Maya that you can find on the Fab Store, but we found that this was slowing us down, and our old expand joints procedure was actually much quicker and efficient. So we stuck to that. We just simply had to create an exporter that would export our poses so that we can reuse it inside of Unreal pose drivers. And then the backward solve is something that we also introduced. This is very simple to implement, and it allowed us to harness some of the functionality in animation sequences inside of Unreal.
The question of the backward solve was not common for us,
Yeah,
to do that in Maya.
yeah,
right?
no,
Yeah.
no, absolutely not. I worked with mocap before, and what we basically had to do was we had to take our keys on our mocap skeleton and bake that onto the controls. But we had to create a script to handle that. And yeah, it was really annoying, but the backward solve is a very elegant way to solve that problem because, yeah, it's built into Control Rig and it's a very simple system and you just work with nodes. Quite elegant, yeah. With our intention going all in on animation, support and development had centered around this phase. There was a strong desire for a picker. So what we did for the body, we piggybacked off the MetaHuman picker, and we just adapted it to work with our rigs. And then for the facial, the animators had a long list of requests. They actually wanted more than a picker, they wanted an interactive GUI. So thanks to the flexibility of the utility widgets, we were able to achieve that. So what we've got is we've got buttons that are actually also sliders. So you can use the sliders and that will interactively update the actual rig. So that was very, very, very easy for us to achieve with utility widgets.
One thing we noticed in Unreal was how it handled animation libraries. It was a bit different to what we were used to. We actually needed a way to store the original keys from Control Rig as actual animation libraries. And so we got a little bit of inspiration from some third-party tool in Maya, and we got to work implementing something that the animators were used to. So we just called it animation library. And because this tool is still relatively new, it doesn't have the full feature set, and hopefully we will continue to expand this in the future, or maybe if Epic releases something along those lines. Another aspect that needed some form of automation was setting up the level sequences. Trying to create this manually by hand was just not going to work. There was just way too much happening in the nested hierarchies that went into it, and trying to remember which track and which subsequences go where and how they should be linked up would certainly drive anyone insane. So thus, the sequence builder was born. The concept is pretty simple. The tool would read timings from an EDL that editorial pushed out, and the sequence builder will build out the level sequences based off a predefined template. Before going on into how we structured our level sequences, we just need to talk about how we built the level sequences the first time round. During this time in our journey, we had a bit of debate around how we should structure our level sequences. Back in the 5.0 days, we had put everything under an episodic route. This was fine because there was only one location and it was just a test. Our episodes in a full production, they would contain multiple locations and probably thousands of assets. So we had to come up with a different structure that would fit those needs. We had various discussions and debates, and ultimately we would split our choice between a shot route-based hierarchy or a sequence route-based hierarchy. After many meetings and debates, we came to the conclusion we would combine the two ideas to form a hybrid structure and thus keeping everybody happy. So this hybrid structure allowed artists to decide which entry point works best for them. If you're in layout and you needed the full context of the shots within the sequence, you would go through the sequence route. If you were an animator or you just needed to work within the shot, you would enter from the shot route and you will have everything that you need. This worked pretty well for us for a while until we hit a binding issue with a very edge case when certain spawnables get possessed by a different subsequence within the shot. If the binding happened from the sequence route, then the binding will just break when you go in from the shot route. And I'm pretty sure that the reverse is true if the binding happened in the other direction. Due to this problem, we had to have another discussion in changing the structure again. And so we arrived at going for the shot route-based hierarchy. Now, even though we'll be embracing this for our current productions, we left layout where it is in the sequence container. The way we deal with layout is probably a topic for another day. But thanks to the sequence builder, we were able to make this change very quickly just by changing the template. This change is fairly new, so that brings us to the present day. We are currently using Unreal 5.5. This version introduced numerous improvements and has already received a lot of feedback from our animation team. Although the time with this version has not been very extensive, it does mark the first exploration into our Unreal hair and fur workflow. And on the subject of hair, I'd like to just take a moment to briefly explain how our hair and fur kind of works in Maya. I'm quite confident in saying that we have a pretty solid hair and groom pipeline for our Maya-based projects. We use Yeti for Maya to do all of our grooming, and as streamlined as it can be, we do run into a few problems, especially around performance in the viewport. And this issue actually required us to make use of proxy representations of the hair, and a lot of the times it wasn't very accurate, and on many occasions we would get cut-throughs during final renders. And this is probably the last place in the render pipeline you want to see this type of issue because it generally requires a rather expensive re-render. On top of that, we also had to resort to switching out this proxy representation during lighting and rendering. Sometimes this can be a costly operation depending on the complexity of the asset or the number of groomed characters within the scene. And so when we started exploring hair and fur in Unreal, we were quite surprised. We were able to get real-time feedback in the viewport. And because of this real-time feedback, the hair is also very quick to iterate. We don't have to wait on any form of renders to complete. The quality of the output is definitely on par with traditional renderers, and the real-time dynamics works reasonably well, and it's quite powerful. And the important part is during animation, the animators actually get to see the hair. So if there are any cut-throughs or whatever issues, it can be seen straight away and can be fixed on the spot. What you see at the moment is one of our main characters, Karma, and she's dancing in real time at 60 frames per second. So this groom process in Unreal is fairly new to us. as mentioned earlier, we have a pretty extensive Yeti pipeline, so we would make use of that to groom our hair. And Yeti also provides the facilities to export the hair out as Olympic curves, and then those curves can get imported into Unreal, and then they get bound to the asset. It seems like fairly standard procedure, and there are some areas that we would like to do a little bit more exploration. From the export point of view, we need to find a way to sanitize and check these curves, because Yeti seems to perform some form of curvature-based subdivision. So whatever point count that you start from the beginning might not necessarily be the same when you do the export. So that means we have to be very mindful of the 255 point count limit when we bring that into Unreal. And then from the rigging point of view, the rigging team would like to have control over the placement and order of the guide curve controls. Since the skeletal meshes for the rig guides are derived from the guide curves, we have to define a process that allows the joint chains that are set up at the Vaults team to become the guide curves we use downstream. Again, this is very early stuff, early days for us, and we will most likely be continuing our investigations within our full productions.
So the former graphs were powerful from the very beginning, but they were really hard to take advantage of. But thankfully, the Epic Dev team heard the feedback and simplified the deformer graph with functions, variables, and pre-made deformers. But even better than that, now you can create deformers right inside of your control rig. So what this meant was that, say we have a head squash and stretch, we can implement that into our head module, and the rigger doesn't even need to worry about the deformer graph, touch the deformer graph. This was huge. I think this would really make it a little bit more easy for us to use. And then modular control rig is a powerful feature that uses the full graph, the full architecture of control rig, but it's a snap to build rigs with the drag and drop interface. It's a very powerful feature, but we're not sure if we want to give up the flexibility that we have from the control rig graphs. So we're sticking with that for now, but we're always evaluating this. And then layered control rigs is also a nice added feature. What this allows you to do is to put a control rig and layer another control rig on top of it. Or you could take a control rig and layer it onto your animation and then still use sparse keys to edit your animation. And it's non-destructive, and you can keep layering them. You can even layer completely different control rig modules if you want different behavior. So that was quite powerful. And then there's rig variants, which again honestly felt like the dev team read our minds. We were in the process of actually building a tool that would actually help us swap out our versions of our modules so that we can selectively update modules on control rigs. So rig variants actually help us do this very easily, and we didn't need to finish out the tool. So that was great for us. And then finally, animation deformers is something that also gives a lot more power to the animators. If you needed a little tweak in a shot, you could add like a sculpt deformer. If there's cut through, you can add a sculpt deformer. If you need a little bit of extra squash and stretch, you can add a lattice right there in the sequencer. So this was really powerful, and this allows those little edits to happen without going back to the rigging team. So that's power, and it gives power to the animators. So what we did at this stage is we simplified the module inputs. So we had like a very long list of module inputs. So we reworked all our modules so that it's got maybe 4 input variables, and then also the control size is also another input. And this just helped speed up the creation of a control rig graph for a character. And then there was another production need, which is groom rig. This is something that we've managed to achieve in a project that we've done, but we don't have all the answers yet, and we're looking to improve on this. And then templates and best practices is something that we put in place so that we ensure all our rigs kind of speak the same, all our riggers speak the same language and we can read each other's graphs. So that was really important. And it's also templates for modules as well. All the modules will have a same structure. And then finally, tweakers is really important for us. So this is basically when you layer controls on top of your main deformation, and it is additional to your main deformation, and you don't disturb the main deformation. So this is really critical for us, especially on clothing. It helps us to avoid cut through, and you can still keep your underlying deformation very clean. So that was really, really, really great that we could implement that thanks to updates in the deformer graph. So for us, it all comes down to this. We now have fully lit texture, high-resolution characters running in real time, and the quality is shockingly close to final pixels. And what's incredible is that this performs better than what we usually see in Maya, even when we are working with low-res, unlit, gray-shaded blobs. There's no more waiting for renders just to see what something looks like, no more play blast, no more guesswork. If a texture is stretching, or geometry or groom is cutting through, we can immediately see it and fix it. That instant feedback has changed the way our artists work, and it's given us a huge boost in both speed and confidence. It's more than just faster, it's more accurate, more confident, and more collaborative. Everyone from animation to lighting to direction, everybody works with the same high quality images or assets. And that's a game changer for us.
We're quite excited at where Unreal is heading. Even for some of us that don't make games, we enjoy all the features that gets released within a very short time span. It seems to resemble our fast-paced nature of our animation schedules. Just before we conclude, there is still a list of many things that we like to explore. Some of these some examples include variants. Our existing Maya pipeline has a very comprehensive way to deal with variants. So we're currently in the middle of investigating what is the best approach in Unreal and would like to see what mutables can offer us. I know we've been talking about skipping the comp phase, but we would like to explore a lot more of the render pipeline and how CryptoMat will fit into this. Ornatrix has been on our radar. It's a third-party hair and fur plugin. So we'd like to see how that would improve our hair and fur pipeline.
So thanks again, everyone, for having us. And it's been fun sharing our progress with everyone. And we can now open the floor for questions. Questions?
Hello, thank you for the presentation. It's really good.
Pleasure.
I was an animator, but right now I teach 3D animation in college. I have a question about the file management actually.
Oh yeah?
Yeah, when I was animator, actually my animators, we keep the file for each shot in one file in Maya.
Mm-hmm.
And the referencing system is quite good, right, in Maya, such as character referencing, props, sets, and so on and so on.
Yeah.
How do you manage from the old pipeline Maya into this kind of pipeline for the file management?
So we actually still retain the old file management, which we use in Maya, because there are still some aspects that Unreal cannot handle, like the actual modeling side of things. So that it's using just a flat file structure that sits on the network somewhere. We do have various tools that make use of that. We just call it Asset Manager. And then we have a process of exporting that into Unreal.
Yeah.
And those become Unreal assets.
Yeah.
Yeah,
But
yeah.
in Unreal, your assets are also, it's got actually
Yeah.
has a much better referencing system. All your assets are actually always referenced. It's always live. So you pull it into your shot, it's basically referenced in, but it's just more dynamic. Everything is live. So you can make a change directly to your control rig. You can see how it's affecting the actual character in the shot. That's really powerful as well.
Yeah. And then when it goes into Unreal, we use Perforce for file management and versioning of all of that stuff. Yeah. Hope that answers your question.
Yes, actually, yeah. Thank
Okay.
you.
Yeah.
Hi. Check. Hi.
Oh, hey.
Thank you very much for the talk. It's very inspiring.
It's a pleasure.
As someone who is just diving into controlling, I just finished building, now writing a lot of Python scripts for modules in Maya. So I could imagine how much time it saves.
Yeah, it's great.
for the control rigs. And one of the problems, as you've mentioned before, is the skinning process, right? The weight paints process.
Yeah.
Which, I don't think Unreal is ready, especially we're using NG skins in Maya.
Exactly.
So I just want to clarify on the actual rigging pipeline, right? So
Yeah.
do you place the joins in the skeletal editor in Unreal and then export it to Maya?
No. What we do is we just use our existing rigging process in Maya. So we've got our own rig builders. So first you generate your guides, and then you would place your guides, and then you generate the rig around that. So, and then we take that and we publish that to Unreal.
Okay. So
Yeah.
you do still
Yes.
have a rigging pipeline in Maya and
Pretty
then
much.
use the skeleton, export it there, and use
Yeah,
rebuild
exactly.
it in the control rig. Okay.
Exactly. So that was like what I mentioned earlier about it was that was a bit of a crutch for us to just, in case we needed to, we can fall back and animate in Maya. But we've kept that. That's kind of the only way that makes sense right now. But the Epic devs have told us that they're actually looking at implementing NG skinning-like system into the skeletal editor. So that's very exciting, and we're really looking forward to that. Like, I think, a lot of the problems that we're facing right now is from when we, if there's a small update requested by the animators, we have to go and republish everything and re-import it. And there's a lot of things that can go wrong during that stage. So I would love for us one day to just stay in Engine and say goodbye to Maya. But yeah.
So when there are changes in the control rigs for the animators for the request, do you also update the rigs in Maya as well?
Well, it depends what the problem is. If it's a skinning issue, you'll have to go back to Maya. If it's a joint position issue, yeah, we go back to Maya because we have to keep them in parity. Otherwise, we're going to have issues when we do later publishes. So everything needs to be done from Maya, and it's like go through that process all over and over again.
Okay, thank you.
Cool, thank you.
Hi. So my
Hi there.
question is, what's actually drive you guys to change to Unreal? I mean, most of us are Maya based.
Yeah.
PC, right? So there
Yeah.
must be a drive
So-
to do that.
Well, initially it was cost.
Cost of Maya, right?
But even still, there is still some form of cost savings.
Yeah.
There is still a cost saving. And
the power of nanite and
yeah,
what's the other one?
Lumen.
Lumen. Like that was very alluring, and we didn't even know about control rig at that point. But once I looked into control rig, I was also kind of I see big potential in control rig. So from a rigging point of view, and also for animators, and the rate of development of the animating tools as well, like that's something that excites us, and I think it's going to look very different than even 2 years from now. And I think the landscape will change. I think more people will be animating in Unreal. I'm very sure of that.
And then from a rendering point of view, essentially, there's a render farm that we probably will be scaling down to something that I don't know what the numbers are,
Yeah.
but it's probably you know,
how many nodes
how many fingers I have on my hand. Yeah.
how many nodes do you like have it before? Like,
Well, the Dublin studio, I'm very ashamed to say that number, but our Bali studio has a more impressive number. I believe it's like 200 nodes or something like that.
Yeah.
Yeah. But there's talk of scaling it down a lot for the
Yeah.
Unreal productions because we're able to render an episode within 24 hours before it took like an actual week to render an entire episode. So just
Yeah.
thinking about that time difference is big. Yeah.
So those are the kind of motivations, you know, for us.
Yeah.
So I remember back in the day when, a long time ago now, I used to work in Flash.
Oh, Flash.
I did apply for a job with you guys, but I worked in Toon Boom and I looked at Flash and I was like, no.
Oh, right.
But I'm still in 2D and I was wondering what you guys think about maybe using the same setup, but for 2D. So you can still rig 2D characters.
I think you could do a lot with it because with the shaders, but you know, it might be you might need to know a lot about setting up shaders as well.
Yeah.
But I think you can. There's a lot of potential there because you could maybe use the skeletal editor to get some deformation, and then you can also use like sprites or something to you know.
To automate.
Yeah.
Brilliant.
But I can see that could be useful. I don't know how efficient it would be, but
versus Toon Boom,
but I think
no
it's technically
rendering.
possible. Yeah.
Yeah.
It's the rendering again.
Yeah.
You know. Thank you.
Cool. Thanks.
Hi.
Hi.
Hello. Can you hear me?
Yes.
Oh, yeah. Hi. I just wanted to know when you start to gathering all the animators into Unreal Engine, you already have an animation library, or they have to like redo everything per shot.
You know,
We've worked on small scoped projects at this point, so they were just animating everything in shot. They might do 1 or 2 cycles ahead of time, but we do see us in our full production. We will, like we typically do, create a animation library, and they'll have to create those from scratch. But that'll be reused on all the shots.
So in the very first start, animators have to like copy and paste all those keys by themselves, right? If they have to like using the same loops in every sequence of the character.
That's
yeah. So I think we touched on that animation library tool. It's very inspired by Studio Library.
So the idea
we're
is
trying
to use
yeah, we're trying to mimic that functionality
Oh, you got it
within
from
our
the first start.
well, the second start. Yeah.
But we've heard a little birdie tweet that the Epic guys might be working on a library like that for Control Rig. So fingers crossed that we can put that tool to bed.
Thank you very much.
Cool. Cool. Is that everyone? All right. Thanks, everybody.
Thank you.
Appreciate it.
Thank you.